In this video, we're going to talk about what some good sampling methods are. How can we take a sample that is representative from the population? What are the mechanics of doing that? So as you can see on page 6 of part 1, there are a ton of good sampling methods listed here. And there's a lot of words on the page. So rather than walk through all of this, I'm going to go ahead and just give you some examples with you guys, my class, as my population. So let's say, here's you guys. I'm too lazy to draw like 46 people, little heads. So let's just pretend that you guys are my population. And I would like to take a sample of you, right? So option number 1 is to just take a simple random sample. So a simple random sample, everyone is equally likely to be chosen to be in my sample. So let's say my population are the 46 students in this class. So that's just one of my particular classes, right? I know I have 3 sections, but one of those classes. And let's say I just want to get a sample of 10 students. To do a simple random sample, I could just have everyone we have a hat at the front of the room, right? A sweet magician hat. Has a thing, right? It's black because it's a magician hat. It's a terrible hat. Terrible hat, but bear with me. So we have our sample. We have our population. What we would do is we'd have everybody write their names on slips of paper. Taylor, Olivia, right? And we toss them the hat. And then I would just grab, that's my hand, and grab 10 people's names, right? That's all a SRS is about. So an SRS is like picking names out of the hat. And I'll use SRS because I'm lazy, but it's a simple random sample. It's actually the thing that we're required to have for almost every calculation we learn in this class. And in fact, there's a terrible upper division class, Stat 560 at SDSU, where you can learn the calculations for all the other methods. It is terribly boring, and you just do a lot of bitch work where you calculate stuff. So that's an SRS, picking names out of a hat. You can use a random number generator, so everybody has a number on my roster. I could easily go online and say randomly pick numbers. In fact, I'll just go ahead and do that so you guys can see what that would look like. So I've pulled up R right here, which is the program I use for all of my stats for my dissertation and all my classes. So there happens to be an R command called sample, which I can sample, let's say 1 through 46. I can choose 10. And it's just going to pop out 10 numbers. So I could do that all day. I can choose a sample and ask the 24th person on my roster, the 16th person on my roster, so forth, so on. So I can do that using a random number generator. Really old textbooks will have a random number table in the back, but in this day and age, almost everyone just uses technology to do this random selection for them. So that's an SRS. All right, so, well, one of the things that can happen with an SRS is because it's completely random, you could end up with a group that is very similar in some way, right? I could end up, when I take this sample, everyone I happen to sample is female, right? And that could be an issue if I'm worried that that might have an influence on my outcome. If I really wanted to be able to look at gender, I need to make sure I had men and women, right? So that's where stratified sampling would come in. It basically allows you to make your sample look like your population with regards to some characteristic. So for a stratified sample, if I was worried about gender with a stratified sample, what I would do is I'd have 2 hats. I'd have everyone who identified as male throw their name in my M hat, and everyone who identified as female throw their name in my female hat. And then I would have people pull out, I would sample, randomly pull 5 of each, giving me my sample of 10, right? And let's just say most of the time, I haven't done the survey yet this semester, so I don't know what the breakdown is, but usually my classes end up being predominantly more female. Usually have about 60% female in my class. And if that's the case, I could do the same thing. I could have 6 and 4. So I could make sure that my sample looked just like my population in terms of its gender demographic, right? And these hats could be based on anything I wanted them to be. So what I label these hats is just dependent on what I'm interested in and what I think might potentially influence whatever I'm measuring. So this is a stratified sample. You think of it as like strata of the earth. If you took like a little section of the earth, right, you have all these different layers, and you're pulling a little bit of each layer. So that's sort of the idea. All right, so the one issue with stratified is it can be kind of a pain in the ass. Not only do I have to own 2 hats, but then I have to separate people and throw them into the hats, and it's just more work, right? So another option is what we call a cluster sample. So a cluster sample looks for a way that our population is already divided up, preferably already divided up in what we would call heterogeneous groups that are already mixed up. So imagine in our classroom, right, as you go down each row, they are males and females in every single row, right? I might have a random row that's all females, but most of the campus, it's pretty mixed up. So I could look at each row of the class and say, well, in every row of the class, this is where I would be up at the front. Yay! Each row is different, right? There's got students from the front who might be the people who are like more the go-getters, right? They showed up early on day 1 to get snag one of those front seats. You got the people in the back who are trying to avoid eye contact with me. We've got this whole gamut, and we have men and women in every column, right? Every row. So in this case, I would take my hat, which I'm not going to pause for, so it'll be another ugly ass hat. Not that my other ones were very nice. And instead of putting names in the hat, what I'm going to put in there are the different rows. So every row is going to have a little slip of paper. And so when I sample, in this case, I'm going to sample out, and maybe I'll pull row 3 and row 6. And in this case, each of my rows have 5 people in it. So I'll have 5 from row 3, 5 from row 6. So I'll get my 10 people, right? And I know that's not how many, there's more on each row, but let's just pretend, right? So in this case, this is a heck of a lot easier than stratified sampling. I'm able to pull, I don't have to write down everyone's name. I'm not writing down 46 names, I'm writing down 8 rows instead, and then I'm just pulling 2 rows. That's a heck of a lot easier. So this is what we call a cluster sample. And the big difference for students to recognize here is in stratified, we're going to each group and we're taking a little bit. And we're still sampling people, right? Just like in an SRS, we have people's names, right? People, people. Whereas in a cluster, we're sampling the groups themselves. A lot of students just get distracted by the idea of groups, and then they don't pay a lot of attention to the mechanics. So I could easily say the same argument for a stratified here. I'm going to take one person from every single row, and that will be a stratified versus taking an entire row. So taking an entire row versus taking just one person from each row, that did not work. That is a cluster versus a stratified. So pay attention to the mechanics. Again, you'll find a bunch of examples of this on the homework that you can try out. All right, so the last of our good sampling methods is probably the easiest in terms of identifying it, and that's what we call systematic. For systematic, it's our simple random sampling with a system. So let's just say we could either use the classroom or we can use the roster. So I'm going to go ahead and use the roster. So I have a class roster, right? I will draw it out. 1, 2, 3, 4, 5, 6, blah, 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 blah. All right. I'll keep going. Now, with systematic, what you're going to do is you're going to choose every however manyth person. So in this case, we want 10 people. So there are 46 people in both of our classes, right? If I want 10, I'm going to need to take every 4.6 people. So roughly every 5th student. Let's just go with 5th student. So we don't want to just always start with number 1 because there's nothing random about starting with number 1. The first person alphabetically is always going to be in my sample. So normally what we'll do is we'll roll a die or do something like that to figure out where we're going to start. So being a stats teacher, I own a lot of dice, so just assume that I'm actually doing this. I roll a die and I get 1. Ah, well, that's hilarious. But so that means I'm going to start with the first person. They're in my sample. And I'm going to count, and I'm going to go 1, 2, 3, 4, The next person, fifth, is in my sample. 1, 2, 3, 4. Fifth is in my sample. I'm going to choose every fifth person, starting with number 1, until I get to my 10 that I need for my sample. So that's a systematic. It's simple random sampling with a system. And you'll always see something like fifth or fourth or 12th, whatever it needs to be so we get our correct number that we're looking for. So those are our 4 good sampling methods. If you go back to my original, the terrible page of way too much writing, you can see that there's one more in the good, which is multistage. A lot of the time, if you're dealing with a sampling frame and a really large population, you may do some sort of combination of these things, in which case you'd be doing a multi-stage sample. So maybe you divide the country into the four regions based on time zones. And then from each region, you make sure that you talk to 2 colleges from every state or something. So you're already got like this stratified thing, but then within the colleges, you want to talk to students about Social Security. So you're going to randomly select 10 students from each college. So now you're doing like a stratified within a stratified. Or maybe it's all of the students within that one college. So you're doing a cluster within a my point is, it can get more complicated than this. And then the math gets even worse. We also have 2 poor sampling methods. Voluntary response is when you just go ahead and like blanket out a survey, and anybody who responds, you count them as part of your sample. As we saw with our political scientists, the people who are the most opinionated about whatever you're surveying about will be the ones who respond. And then convenience sampling, selecting the individuals that are easiest to reach. So in my case, if I want to know about stat students at Mesa and I only talk to my classes, well, that's convenient because they're my classes, but I'm leaving out everyone else. And it's the same thing with our political scientist, right? She had both of these because she only talked to students at her college. So those are our sampling methods. I will give you a break because that was a long-ass video, and we will jump in with exercise 1.4.3 in the next video.